Welcome to Module 1 of the Machine Learning Foundations for Product Managers course. In this module, we'll provide a gentle introduction into machine learning. We'll focus on answering the question, what is machine learning? So we'll start with a little bit of history. We'll cover some common definitions for machine learning so that you understand what it is and what it does. We'll then talk about the types of problems that machine learning can be applied to, and why it's such an exciting field and there's so many applications of machine learning out there in the world today. We'll then dive into a breakdown of the machine learning tasks, focusing on the different types of tasks that machine learning is applied to, such as supervised learning, unsupervised learning, and reinforcement learning. We'll also begin to build our vocabulary around data science and machine learning terminology, so that we're able to start to understand articles and have conversations about machine learning. Let's start with the basics. First off, what is machine learning? Arthur Samuel, an IBM engineer, first defined machine learning in 1959 as a field of study that gives computers the ability to learn without being explicitly programmed. So the main idea here is that instead of providing a computer with exact instructions to solve a problem, we show it examples of the problem to solve, and we let the computer figure out for itself how to solve the problem. So an example I like to give is, let's say we'd like to train a model to recognize hamburgers. In the traditional method of programming computers, we would provide explicit instructions to the computer of what a hamburger is. So we'd tell the computer a hamburger consists of 2 buns with a darker patty in the middle. Possibly we'll have a piece of cheese or lettuce on it, and that's a hamburger. Using machine learning, rather than providing the computer with any instructions or definition of what a hamburger is, we would simply show the computer many pictures of different hamburgers. And over time, the computer would be able to learn for itself and recognize a hamburger. Let's now take a look at the difference between how traditional software generates predictions and how machine learning generates predictions. With traditional software systems, we take a set of input data and a set of rules that we provide to the software system, which the system can then use to generate new outputs. So in the previous example of classifying an image of food as a hamburger or not a hamburger, we would feed our software system a set of input data, or images of food in this case, and a set of rules for what constitutes a hamburger. The system would then be able to apply those rules to identify whether each image in the input data was a hamburger or not a hamburger. Let's now take a look at how machine learning would solve this problem. With machine learning systems, we provide the input data and a set of previous outputs. The machine learning model then figures out for itself the rules or patterns behind what constitutes a hamburger. It can then use these self-learned patterns or rules to classify new input data as hamburger or not hamburger. So one common question that we see is, what is the difference between artificial intelligence and machine learning? Artificial intelligence is the broad field of trying to replicate aspects of human intelligence in machines. Machine learning can be considered as a subset of artificial intelligence, which is focused on a set of methods and tools to help realize the goals of the field of artificial intelligence. Another common term, deep learning, can be defined as a subfield within the broader field of machine learning. And deep learning is focused on the use of a specific machine learning model called a neural network to accomplish the goals of machine learning. Finally, we have some other smaller subfields focused on accomplishing specific tasks using machine learning or possibly deep learning, such as computer vision to detect objects in images, or natural language processing, and finally recommendation systems, such as the type of systems you might see on product websites of your favorite store, providing personalized recommendations to you. So let's cover a very brief history of the field of artificial intelligence and machine learning. The origins of machine learning actually date back to the early 1800s. Things like the least squares regression or Bayes' theorem are machine learning algorithms, which are actually still in use today, and their origins date back to statistical principles discovered and published in the early 1800s. The field of AI was really launched, and the term AI was coined in the 40s and 1950s. And that began in 1943 with the proposition of a simple artificial model of a neuron that exists in a brain. And that neuron was then extended to the idea or the concept of a full neural network throughout the early 1950s. However, by the late 1960s and early 1970s, many folks throughout government and scientific research had become disillusioned with the field. It was hyped up during the 50s and 60s with the significant progress that was made, and the field, unfortunately, was not able to live up to the lofty expectations that were set. So as a result, funding was cut, and machine learning and AI researchers turned their attention elsewhere. In the late 70s to 1980s, research again picked up, and many of the algorithms that are most commonly used today, both in the broader field of machine learning as well as specific to the field of deep learning or the use of neural networks, were developed through the late 80s and the 1990s. Finally, in the 2000s, starting around 2009 until the present day, we've been going through what's called the deep learning boom. And the attention of the broader field of machine learning has really focused on the application of deep learning or neural networks to achieve incredibly difficult tasks that previously were considered impossible. And we've made tremendous progress over the last 15 years or so in applying deep learning. So let's talk a bit more about machine learning and where it is as a field today. Machine learning has become a pervasive part of our world, and as consumers, we may interact with machine learning models dozens of times a day through a variety of different products and systems that we interact with. Often we don't even know that we're interacting with a machine learning model or an AI technology in the background. The popularity of machine learning, in particular in recent times, is due to a couple of main factors. The first one is that there's been an explosion in the amount of data that we have access to. That's been driven by ubiquitous internet connectivity, that we're now connected to more and more people, computers, and even devices. We've seen drastic advances in sensor technology that allows us to collect massive amounts of data from sensors of many different types. And finally, our devices themselves have become intelligent and connected, meaning that they're able to produce data about their environment, about us, and about our usage, all of which can be used to build machine learning models. Secondly, the field of deep learning, or the use of neural networks, has made things that previously were considered impossible now possible. And key drivers of that have been a massive increase in computational power, in particular through what's called graphics processing units, which are used to train very large, very complex machine learning models. Secondly, we've seen efforts by scientists and researchers and other people working throughout academia and the corporate world to assemble huge sets of what's called labeled data, which is available for training very large, very complex models. And thirdly, we've had significant breakthroughs and algorithmic advances, which have allowed us to build innovative machine learning architectures to accomplish very difficult tasks. So let's look a little bit more about where we find machine learning in our world today. One common example of machine learning is in product recommendations. If you go to a website for your favorite store or online retailer, or if you're looking to listen to a song or watch a movie, generally you'll interact with an AI-based product recommendation system, which learns about you and your personal preferences and is then able to provide personalized recommendations. Another example of machine learning in our world today is spam filters for our email clients, which are able to distinguish between real messages which we received versus spam messages. The routing of mail to us at home is accomplished through the use of machine learning via what's called optical character recognition to recognize digits as well as handwritten letters and words on envelopes and help the Postal Service get our mail to us at home. Finally, things like credit card fraud detection are driven by machine learning algorithms, identifying and distinguishing between normal patterns of spending versus when there's a likely chance of credit card fraud.